Hello everyone, welcome to another episode of Stonks Maxxing, day 144. So this one I do want to go over the earnings release of Confluent. Guess I can just watch here on the webcast. Let's see. I feel like you guys already know my email. It's about an hour.
I'm Shinzi from Investor Relations, and I'm joined by Jay Krebs, co-founder and CEO, and Rohan Sivaram, CFO. During today's call, management will make forward-looking statements regarding our business, operations, sales strategy, market and product positioning, strategic partnerships, financial performance, and future prospects, including statements regarding our financial guidance for the fiscal first quarter of 2025 and fiscal year 2025. These forward-looking statements are subject to risks and uncertainties which could cause actual results to differ materially from those and cause actual results to differ is included in our most recent Form 10-Q filed with the SEC. We assume no obligation to update these statements after today's call except as required by law. Unless stated otherwise, certain financial measures used on today's call are expressed on a non-GAAP basis. These non-GAAP financial measures internally to facilitate analysis of financial and business trends and for internal
So reading my previous
and should not be considered in isolation from or as a substitute for financial information prepared in accordance with GAAP. A reconciliation between these GAAP and non-GAAP financial measures is included in our earnings press release and supplemental financials, which can be found on our IR website at investors.confluent.io. References to profitability on today's call refer to non-GAAP operating margin unless stated otherwise. With that, I'll hand it over to Jay.
Thanks, Shane. Good afternoon, everyone. Welcome to our fourth quarter earnings call. I'm happy to report we exceeded all guided metrics. Subscription revenue grew 24% to $251 million. Confluent Cloud revenue grew 38% to $138 million. And non-GAAP operating margin was 5%, our third consecutive positive quarter. These results highlight our customers' need for a complete data streaming platform, our world-class innovation engine, and our successful transformation to a consumption-driven data model. I'm also thrilled to announce a major expansion of our strategic partnership with Databricks. This collaboration brings together Confluent's complete data streaming platform and Databricks' data intelligence platform to empower enterprises with real-time data for AI-driven decision-making. The bidirectional integration between Confluent's Tableflow with Delta Lake and Databricks UnityCap
With that, let's talk about Confluent. Talk about Confluence. Okay. Currently, how did I forgot how I structured my other. Confluent is the world's an enterprise software company that builds on the cloud and helps manage Kafka deployments for companies adopting an event-driven companies build data streaming pipelines. Their bread and butter product is the bread and butter product is a service to help manage Kafka deployments for companies that don't subtracting away the unnecessary complexity of dealing with software infrastructure. Data This software infrastructure makes sense.
Catalog will provide consistent real-time data across operational and analytical systems that is discoverable, secure, and trustworthy. Built on open standards, these integrations ensure real-time interoperability and flexibility across diverse ecosystems, seamlessly working with the tools and data infrastructure that companies already use. Operational data from Confluent becomes a first-class citizen in Databricks, and the insights created within Databricks can be driven back into any processor in the enterprise via Tableflow and Confluent. This is an incredibly exciting prospect for companies worldwide. This partnership extends Tableflow's reach across the analytics ecosystem, positioning Confluent as the leading vendor for delivering data across the enterprise. This is crucial for scaling AI innovation by giving application developers, data engineers, data analysts, and data scientists a single real-time source of truth to power advanced analytics and next-gen AI-driven applications. Additionally, our partnership with Databricks includes comprehensive go-to-market efforts encompassing field and partner enablement, solutions architectures, co-marketing, and co-selling initiatives. Together, we will enable businesses to harness the power of real-time data to build sophisticated AI-driven applications for their most critical use cases. Tableflow continues to be one of the most exciting and powerful additions to our data streaming platform. Tableflow exposes Confluent's data streams as continuously updating tables in cloud object storage using open standards like Apache Iceberg and now Delta Lake. This allows Confluent to act as the bridge between operational systems that run the business and analytical platforms like Athena, BigQuery, Databricks, and Snowflake that extract valuable insights. Historically, operational and analytical systems operated in separate silos, managed by different teams and composed of different technologies and workflows. To compensate, teams built point-to-point batch-oriented pipelines to move operational data to the analytical estate, resulting in insights based on outdated and incomplete data. In the era of real-time data and AI, scale data simply isn't enough for modern businesses. Data streaming has emerged as a major data platform, putting Confluent in a unique position to replace the brittle connections between operations and analytics with something that is much more robust and much more scalable. In fact, our mission and business model is built on creating continuous, trustworthy, and discoverable streams of data that can be consumed anywhere in the organization. Tableflow further realizes our mission by making real-time, consistent, and secure data available as structured tables in cloud object storage using an open table format. With Tableflow, data is defined and stored once, but accessible across multiple processors, breaking down silos and enabling faster, more accurate insights. Tableflow was met with excitement across our customer base and is already delivering real benefits to early customers. Take a U.S. digital native customer that
Okay, so
Yes, yeah.
I'm gonna pause that real quick. Take a look here. Snowflake, Amazon, Athena, Dremio, Imply, Starburst, Onehouse. Okay, so now they're just adding on Snowflake. So they added on Snowflake, Amazon. Now they're adding on Databricks. Operational states the SaaS app ERPs, custom applications, and serve the needs of applications to transact with customers in real time. Analytical state the data warehouses, lakehouses, AI/ML platforms, and other custom batch workloads that support business analysis and reporting. Okay. In the past, there has been tight coupling of table storage and query engines. In recent years, we've witnessed the rise a headless data infrastructure where companies are building up just more open lakehouse and cloud object storage accessible by any number of tools. Setting up the infrastructure to consume, creating configuring consumer groups and connectors, ensuring the consumer groups are balanced, properly sized for the throughput and number of partitions in your topic. Data and data like Parquet, hooking the schema or governance tooling that understands. If the data is a change log, materializing and applying just the data. TableFlow also utilizes a new metadata materializer behind the scenes that taps into confluent schema registry to generate Apache Iceberg metadata while handling schema mapping. Okay, so Tableflow was released or announced back in March 2024. So about 9 months. So partnership data. Data defined once and be spread. Okay. So he announced the launch of Tableflow back in March 2024. Idea was to adopt a singular approach to representing data across different data streams uniformly across different data warehousing / lake storage tools. So warehouses, lakes, lake houses, etc. Since then, Tableflow can be integrated, has integrations with partners, launched with integrations, alongside name brand partners like Snowflake, Amazon, Athena, and now Delta Lake. Operational systems. Wait, is Delta Lake a standard similar to Delta Lake similar to Apache Iceberg? Okay, so what is an open table format? put our CSV. Spark Databricks /on. Make up the current version scheme of the data partitioning information. By leveraging the open table, do you call this a standard? Format Apache Iceberg. So I was gonna make sure. I mean, to simplify streaming data is integrated. Easier for organizations to. Oh, so these are all okay. This quarter table flow received partnership between with Databricks. It's announced. Resulting in the adoption of table. Oh god, I'm so tired. I got no sleep last night. I could feel myself sleeping. Let's go. Let's close. Okay, I think I'm gonna try to do God. Oh god. 20 crashes? Jesus Christ. Okay. Now, table data bricks is partnering with Confluent to add data, to add the open table format Apache data Delta Lake. To table flows. Product offerings. This helps customers easily integrate data streams with Databricks. I think Databricks, Data Lake House. Data platform. Here. Databricks platform. Storage and analysis. Okay. Point-to-point batch-oriented pipelines move on. Okay, confluent table flow. So it does seem like Confluent's product thesis here thesis behind table flow is that traditional batch processing ingestions into analysis tools, Snowflake, Databricks, Athena, is slow and outdated. Developing table flows at traditional path is the belief that tradition. So Confluent's thesis behind developing table flows is the belief that traditional batch processing ingestion into analysis tools is slow and outdated. So this results in so that's what they were talking about. Kind of like the operational in tech jargon, moving operational data to the analytical state. Data produced in the operating state which really means a software application that stores data. A warehousing / lake tool. Data warehouse / lake tool. Okay. I guess that's actually pretty interesting, right?
A seamless online booking experience with accurate pricing and precise arrival and drop-off times. Previously, they did this by loading data into Snowflake with batch jobs for analytics. However, this caused delays and increased data processing costs. So the digital native customer implemented Tableflow as part of our early access program to bridge their operational data with their analytics systems using Apache Iceberg. With Tableflow, Confluent Cloud automatically performs the required data pre-processing and ingests it into Snowflake as high-quality data. The customer can now derive business insights directly from the data faster and at a much lower cost, significantly speeding up analysis and decision-making for its transportation customer.
Okay. I guess that doesn't really tell us anything about Databricks and that partnership. Tableflow. So this quarter we saw Databricks partner. Confluent also provided a helpful real customer use case in the transportation sector, right? It simplifies booking and operations for ground. Okay. Digital native customer, so a customer that Confluent considers to be tech to adopt new technology rapidly. A helpful example, use case example with a digital native customer. So that's really a customer that Confluent considers. Maybe this is Uber. So this customer simplifies bookings and operations for ground transportation companies and requires real-time data for accurate pricing and precise arrival drop off times. Previously, their previous system required batch processing into Snowflake, but found that TableFlow was a cheaper and faster and easier. Faster, allowing them to helping allowing the company to pre-process the data before ingesting into Snowflake. So I'm sure Snowflake might be doing something. I could see why Snowflake is interested in buying Red Panda then, because they could really have this pipeline of sorts. Side note, Snowflake is looking to acquire Red Panda, another player in the data streaming space. Start to see why now. Snowflake, Red Panda. Growth, so okay. So I guess Jay's probably gonna talk about the platform again.
TableFlow is also a great example of what we discussed last quarter. Our third wave of growth will come from being a complete data streaming platform. Over the last year, we continued to see strong DSP momentum in our cloud, connect, process, and govern accounting for approximately
Okay,
14%
so these
of
are
our
the
cloud
prepared
business,
marks.
with consumption growing substantially faster than overall cloud. No other vendor is as intensely focused as us on building and delivering a complete data streaming platform that connects streams, processes, and governs data continuously in motion. This puts Confluent in a highly advantageous position because over time, as more parts of our platform are used, a virtuous cycle of adoption drives stickiness and more growth. Above all else, we believe a complete data streaming platform solves our customers' hardest problems, reduces complexity, and provides substantial ROI. Let me walk through a few customer examples. Zazzle is a global online marketplace and platform for creating and customizing unique designs. The company is built on a foundation of technological innovation that connects customers, creators, and makers, powering the creation of almost anything. As a leading global deliver personalized experiences across its unparalleled range of products and designs. With hundreds of thousands of independent creators making a living through the Zazzle platform, and customers in every country worldwide, maintaining platform performance while eliminating redundant data became critical. So the Zazzle implemented Confluent's fully managed Flink offering to transform their largest data pipeline. By shifting stream processing earlier in the pipeline before writing to Google BigQuery, Zazzle reduced storage and computation costs while delivering more relevant product recommendations, directly impacting revenue. But this is just the start. With this foundation in place, Zazzle plans to expand their Flink usage to additional data streams to further enhance real-time personalization capabilities. A leading European grocery delivery service has also built its data architecture on Confluent's data streaming platform and leverages our Apache Flink offering to optimize real-time order management. This digital-first company manages the entire grocery delivery process, overseeing daily inventory updates without To meet their ambitious promise of delivery within 20 minutes, they require a robust real-time stream processing solution to monitor and manage orders end-to-end, from warehouse to driver to customer. Previously, their reliance on REST API calls and event-driven architectures using open-source Kafka led to inefficiencies, delays, and fragmented data sources. By transitioning to Confluent Cloud with Apache Flink, they now seamlessly process key data streams, including grocery orders and warehouse locations, into a unified order topic that is easy to manage and consume. Flink further enables them to aggregate orders, assign them to delivery drivers, and track driver speed and location to provide accurate delivery time estimates for customers. This streamlined solution has significantly enhanced their order management capabilities, resulting in reduced development costs, minimized downtime, and a faster, more seamless experience for both drivers and customers. A top 3 Fortune Global 100 telecom customer shows the value of a complete DSP. As consumers make calls, send texts, and access the This data then needs to be shared with partners and subsidiaries in real time so they can optimize network coverage and analyze customer use.
Okay.
It was unable to deliver the scale and speed required for the mission-critical cell tower workloads. So they turned to Confluent's complete DSP for real-time visibility and improved scalability across their wireless network. With Confluent's data streaming platform, the telecom provider streams mobile data from 70,000 U.S. cell towers with connectors feeding data into lakes and warehouses. Stream processing provides real-time insights into network reliability and performance of mobile devices and wireless plans, which is then shared with partners and subsidiaries. This allows the telecom provider to unlock new revenue streams by making faster, smarter decisions, ranging from where to invest in 5G capabilities to where to lay down fiber optic cables. Citizens Bank, one of America's oldest and largest financial institutions, transitioned from open-source Kafka to Confluent DSP.
20 full-time employees just support.
Banking customers expect real-time experiences, like immediate fraud alerts and instant access to deposited funds. But with an expanding data footprint, citizens struggle to self-manage open-source Kafka, which requires
It's like
20
$2
full-time
million.
employees to support. So they turn to Confluent's complete data streaming platform. Using Confluent Cloud, Citizens Bank connects data from sources like consumer checking account, credit cards, and FICO fraud scores, generating real-time actionable insights. Stream governance ensures the bank's data is high quality and trustworthy by using schemas to reduce data inconsistencies and ensure compliance. With Confluent, Citizens Bank has reduced IT costs by 30% and saved $1.2 million annually by reducing fraud false positives by 15%.
So like 20
Additionally,
full-time
the bank has
employees.
seen a 20% increase in customer engagement, a 40% faster loan processing time, and a 10-point increase in Net Promoter Score from improved customer interactions. momentum in our Kafka business, including wins in early WarpStream success. At Confluent, our strategy starts with capturing the vast opportunity presented by Apache Kafka, which serves as the real-time backbone for more than 150,000 organizations worldwide. Doing this requires having the right offering to meet the performance, TCO, and reliability requirements of an incredibly wide variety of use cases. In 2024, we invested in offerings to better capture the entirety of this market. One area we targeted was the high-volume, cost-sensitive workloads common in observability, analytics, security, and IoT. Now generally available, Freight clusters are a great offering for this segment. They're designed to attract cost-conscious customers with high throughput, latency-tolerant workloads. We paired this with WarpStream, which serves a similar customer base but allows running directly in the customer's account, adding a low-friction midpoint between self-managed and SaaS. We've seen great traction with both of these offerings in helping us penetrate new accounts, particularly in the large-scale digital native segment, with offerings that address use cases that demand zero-access security and have tolerance for relaxed latency. This is playing out already. In fact, every WarpStream deal closed since acquisition was from our digital native cohort, including companies like Elastic, the search AI company used by over half the Fortune 500, and Cursor, the AI code editor that's become one of the hottest names in AI. And the vast majority are net new customers to Confluent. We're excited for the future of WarpStream and continue to invest in its innovation, including a whole host of new features released in January. One expansion with WarpStream this quarter was with a digital native customer that helps developers access real-time data. Their large-scale and high storage requirements made this a significant cost driver. Previously, they used Red Panda, but as their usage increased, so did their bill. The unsustainable costs, combined with performance issues with Red Panda, led to their decision to adopt WarpStream. Switching from Red Panda to WarpStream delivered immediate benefits for the customer, including nearly 10x cost savings and the ability to handle much higher data volumes on their platform. This has unlocked entirely new use cases for the customer that weren't possible before. In closing, we're pleased with our strong performance this year. The progress we made and the innovation we delivered to customers in 2024 set us up to capture more of the significant market opportunity ahead. With that, I'll turn it over to Rohan.
Okay, I think that's actually a pretty good update in terms of WarpStream. If I'm correct, so WarpStream they acquired in Q3 of 2024, and the whole idea behind that is, I think with traditional Kafka deployments, all of that is disk-based storage. So you store your topics on some type of disk. I guess you could call it a cloud server, so to speak. I think if I remember correctly, and if I think through this correctly, you deploy Kafka or let's say Confluent, they actually deploy Kafka on either AWS, Google Cloud, Azure, and then underlying that infrastructure is servers, right? So on those servers, you do have storage, you have memory, and you have your CPU. I think also on the licensing business that Confluent has, they're deploying Kafka clusters on-premise and also private cloud networks. So there's still underlying infrastructure that I believe the Kafka topics need to actually tap into in order to store their data. Now, what WarpStream does, I think, it abstracts that layer of having to store your data on disk, so either memory storage, and they'll store it in some type of object storage system, kind of like a S3 BLOB type object type storage, where I'm 99% sure the underlying disk doesn't really matter. It's stored. I don't know how this works now that I'm talking about this out loud. I think it is still on disk, but the storage, the object storage itself abstracts that layer so you can directly upload it into that. And then that object storage can run anywhere you want. So that's WarpStream. Okay, let me double check. WarpStream, a way of deploying Kafka clusters. graphics that are stored. Oh, right. It was to avoid some type of interzone availability charge on object store, not disk. Streaming platform, okay. How is warp stream different from confluent? I didn't press. Without managing infrastructure. Okay, maybe let's watch this.
Hey everyone, I'm Richie, and I'm one of the co-founders of WarpStream, and now I'm the head of WarpStream at Confluent. A little bit for BYOC, and what I want to do now is dig into the details a little bit more and talk about the differences between what we built with WarpStream BYOC and the traditional BYOC model that you might be familiar with. So the idea with BYOC is pretty simple, right? Instead of running all the infrastructure in the vendor's cloud account and exposing a secure endpoint to customers, with the BYOC model, the vendor deploys and remotely manages all the infrastructure in the customer's account. This approach has a number of benefits, but the big one that people usually really care about is something called data sovereignty, right? All the data stays in the customer's account, none of the infrastructure at sea, and the traditional BYOC model that you might be familiar with. So the idea with BYOC is pretty simple, right? Instead of running all the infrastructure in the vendor's cloud account and exposing a secure endpoint to customers, with the BYOC model, the vendor deploys and remotely manages all the infrastructure in the customer's account.
Remotely manages. Okay. So BYOC, bring your own cloud.
This approach has a number of benefits, but the big one that people usually really care about is something called data sovereignty.
Okay, I'm gonna be honest, I don't fully understand this. What is bring your own cloud? It's BYOC. Where customers run a vendor software within their Okay. Interesting. So is the traditional model with Snowflake / Confluent that relies on infra to run, say, a Kafka cluster on EC2. So in the traditional model, lies on confluent to run, say, a Kafka cluster on EC2, that each deployment is charged to confluence account, vendor accounts, not a customer account. Call, say, elastic MV. Okay, so the traditional cloud-based SaaS model is one empowers the software vendor to manage cloud deployments and ultimately the data that is stored in that cloud. Gives the key to the data, the key to the city to the software vendor that is selling the software service. Selling the service. That means Confluent Cloud customers are managing for a company like Confluent. That means they have their own corporates, they have their own vendor accounts where deployments for their customers are hosted. Confluent gets charged through that vendor account for cloud, for compute/storage costs, and then passes that cost to the customer via subscriptions/contracts, via enterprise subscription contract costs. Own cloud vendor deployments for their customers. Along to the customer via enterprise subscription/contract costs. Okay.
Right, all the data stays in the customer's account, none of it ever leaves their environment, and this can be really valuable to some customers and workloads that really need it. But of course, like everything, the BYOC deployment model comes with trade-offs as well. And with BYOC, the big one is actually around security. And it's kind of a weird thing to say, right? Like the whole point of this was data sovereignty, keep all the data in the customer's environment, none of it leaving, so why are we making trade-offs around security? Well, the thing you have to keep in mind getting deployed with this BYOC architecture, it's usually really complex technology, right? The data in the customer's environments, none of it leaving, so why are we making trade-offs?
Okay. It seems like it lagged.
Around security. Well,
I'm gonna just watch it here.
Hey everyone, I'm Richie, and I'm one of the co-founders of WarpStream, and now I'm the head of WarpStream at Confluent. And Jay kind of set the stage a little bit for BYOC, and what I want to do now is dig into the details a little bit more and talk about the differences between what we've built with WarpStream BYOC and the traditional BYOC model that you might be familiar with. So the idea with BYOC is pretty simple, right? You know, instead of running all of the infrastructure in the vendor's cloud account and exposing a secure endpoint to customers, with the BYOC model, the vendor deploys and remotely manages all of the infrastructure in the customer's account. This approach has a number of benefits, but the big one...
Okay. Typically can access the hosting vendors accounts via secure endpoints to manage their specific deployments. Flips this relationship around so that the customer deploys in their accounts and is remotely managed by the software vendor. Okay.
That people usually really care about is something called data sovereignty, right? All the data stays in the customer's account, none of it.
Okay. This is a really important milestone to achieve the idea of data sovereignty. The state where all of a data is controlled and owned by you. Is data sovereignty okay.
But ever leaves their environment. And this can be really valuable to some customers and workloads that really stays in the customer's account. None of it ever leaves their environment. This approach has a number of benefits, but the big one that people usually really care about is something called data sovereignty, right? All the data stays in the customer's account. None of it ever leaves their environment. And this can be really valuable to some customers and workloads that really need it. But of course, like everything, the BYOC deployment model comes with trade-offs as well. And with BYOC, the big one is actually around security.
Okay, now this. Legal/regulatory requirements on where your data is stored.
Okay. And that's kind of a weird thing to say, right? Like the whole point of this was data sovereignty, keep all of the data in the customer's environment, none of it leaving. So why are we making trade-offs around security? Well, the thing you have to keep in mind is that most of the technology that ends up being deployed with this BYOC architecture, it's usually really complex technology, right? It's stateful things like databases and streaming technologies like Kafka, things with lots of nodes, local disks, state, replication, consensus, just a lot of moving parts where things can go wrong. And you know, the fact that this technology is complex is why usually the customer is engaging a vendor to help them manage it in the first place. And so since this technology is so complex and stateful, in practice what it means is the customer ends up having to provide the vendor with sweeping privileges, give them access to their account, allow them to jump in, deploy things, upgrade things, give them access, and kind of in the worst case scenario, something goes really wrong, the vendor and their support staff will have access to kind of get on SSH in, get on the boxes and fix things. And so kind of behind me you can see like a very small sample of the sometimes hundreds of permissions that a customer would have to give a vendor in the traditional BYOC model. And so this works, but it's a little bit risky from a security and liability perspective for the customer. And so when we were building WarpStream, one of the things we spent a lot of time thinking about was, was there a better way to do BYOC? Could we address some of these security problems while still keeping some of the benefits? And the thing that we realized is that we could avoid a lot of the problems with the traditional BYOC model by re-architecting the underlying system in a different way. And so we kind of looked at everything from first principles, and the question we kept asking ourselves was, what would a modern data streaming platform look like if it was built today, not only be cloud native, but also BYOC native? And to do that, we had to solve a number of problems, right? The first one we just had to address was the security problem. When we were building it, we really didn't want to have any access to the customer's environment. We didn't want to have any cross-account permissions. We didn't want to do VPC peering. We didn't want us or any of our support staff to have the ability to get into their environment or their machines under any circumstances. We just wanted to avoid all that. And if we were going to do that, then the software that was deployed into the customer's account had to be really simple, right? If we don't have the ability to kind of jump in and manage it remotely, It had to be really, really easy to operate, and ideally it would just be completely stateless, just kind of the easiest thing you can kind of imagine running in the cloud. And we had to solve both of those problems while still maintaining the benefits of the traditional BYOC approach around data sovereignty and keeping all of the data processing and storage in the customer's account with none of the data leaving. And so that's what we built with WarpStream. WarpStream has what we like to call a zero-disk architecture. And so you can look at the entire WarpStream stack, and there's no local disks, there's no write caching, there's no EBS volumes, nothing. And what we do instead is we use commodity object storage as the primary and only storage in the system. And what that does is it increases the latency of the system a little bit, but in exchange we get a dramatically simpler architecture and a system that is much, much more easier to operate. And so if we dig a little bit deeper into WarpStream's architecture, there's two primary components. There's the WarpStream agents and there's the control plane. The agents are basically, you can think of them as like stateless Kafka brokers. They're thick proxies that sit in front of the object store. They handle batching, caching, and exposing the actual raw Kafka TCP protocol to the customer's applications. The control plane runs in our cloud account, and it handles a lot of the trickier distributed systems problems around metadata and consensus. It implements things like transactions and consumer groups and kind of all the things that make Kafka Kafka. And so with the agents running in the customer's cloud account and the control plane running in ours, the only infrastructure that is in the customer's account are these stateless agents that are super easy to manage, right? They have no topic partition leaders, no local disks. You can just add and remove containers, and that's how you scale the cluster up and down. You never have to rebalance partitions. If you accidentally delete all of them, you won't lose any data. Just like really easy to manage stuff. And so this hard split we've created between the WarpStream agents and the control plane kind of addresses the security problem with the traditional BYOC approach, right? We don't need access to the customer's environment because there are no stateful components to manage there in the first place.
Okay.
Of course, someone still has to be responsible for every component of the system, right? And so similar to the cloud providers, we use the shared responsibility model. And so the storage layer is owned by the cloud provider, right? When you deploy a WarpStream cluster, you create an S3 bucket, and the AWS S3 team is responsible for making sure that your data is durable, it's replicated, and that your bucket's always available. On the other side of the spectrum, the metadata and consensus layer is handled by us, right? We make sure that your metadata is always durable, that your control plane is always available, and that we scale the control plane with the throughput of your cluster. And so the third and final piece is the part that the customer is actually responsible for, which is managing these stateless agents in their own infrastructure. And like I said before, the agents are super easy to manage, right? You basically just apply our Helm chart, a bunch of stateless containers appear in your Kubernetes cluster, a CPU autoscaler is automatically configured, and you basically never think about them again. And so this addresses kind of the security problem I was talking about earlier, but we still maintain all of the benefits in terms of data sovereignty, because all the data is processed on the agents running on the customer's VMs in the customer's network and storing data in the customer's object storage bucket that we don't have any access to. And so this is all the security stuff is really cool, but there's actually a lot more to WarpStream than just improved security. And so the other thing I want to talk about is how WarpStream is actually cheaper to run than self-hosting Apache Kafka yourself. And the reason for that is, like Confluent Cloud Freight clusters, WarpStream was designed for the biggest workloads on the planet. Things like observability, logging, IoT, feeding data lakes. Use cases where there's a little bit more tolerance for higher latency, but the volumes of data being processed are really huge, right? And since WarpStream was designed for these massive scale workloads, cloud economics is really top of mind for us when we were architecting the system, and you can kind of see it everywhere in the design. So there are three ways that WarpStream will kind of reduce its cost compared to running Kafka yourself. The first one is around networking. So if you run kind of like a really high scale, high volume Kafka cluster in the cloud, one of the biggest drivers of cost is actually just the cost of manually replicating data between availability zones, right? And with WarpStream, what we do is we use the object storage layer not only as the storage layer, but also as the network layer. And so that allows us to eliminate these fees entirely. The second thing that tends to make Kafka really expensive to run in the cloud is that disks in the cloud are just really expensive. Once you factor in things like replication and making sure that you have enough headroom for growth, the cost of storing a gigabyte of data on a local EBS volume in the cloud after replication is about 25 times more expensive than storing the equivalent amount of data in object storage. And so since WarpStream uses object storage as the primary and only storage in the system, your data is always stored in the cheapest storage medium available in the cloud. And the third way in which WarpStream can dramatically reduce costs compared to running Kafka yourself is around auto-scaling. I'm sure a lot of people in this room are self-hosting their own Kafka clusters, and you'll know it's just really hard to auto-scale a Kafka cluster and to do it quickly, right? Brokers have to be added, partitions have to be rebalanced, a lot of data has to be copied around, your cluster is going to be a little busier while these operations are happening, it's going to consume more resources. Since the WarpStream agents are completely stateless and all of the storage is offloaded to the object store, they're actually trivial to auto-scale, right? You just monitor the CPU. When it gets high, autoscaler adds more containers. When it gets low, you remove containers. No partition rebalancing, no data copying around. And so by default, every WarpStream cluster has autoscaling enabled. And so your WarpStream cluster is always basically perfectly right-sized for the amount of throughput that it's serving right now in the current moment, and not how much throughput you might need to serve sometime in the next few weeks. And so all of these things, zero disks, zero zone networking fees, zero ops auto scaling, and zero access BYOC are why, despite WarpStream being a relatively new product, we've been able to attract a great set of customers that are driving really large workloads through WarpStream. Customers like Grafana Labs, Character.ai, Zomato, PostHog, and GoldSky.
Okay, that's pretty cool to have to say. Understood maybe like 30% of what he was trying to say. But it does seem like, okay, they're landing customers, which is good. So, does come with a trade-off in security. This does come with the trade with security. So I think I should really understand the underlying technology of how Kafka works, because I did hear about partitions, topics, I think shards maybe was mentioned there. Balancing, these are all terms that I wasn't really familiar with. With the trade-off of security, of for complex deployments, vendors typically need invasive access to a customer's account in order to manage in order to effectively troubleshoot problems and ensure Kafka deployments. Does this sound technically right to you? Okay, actually, I do like this. Do not have. Okay. Dedicated clusters. This is what I wrote for BYOC. So software manifold. Okay, I just realized that I do love threes. GPT loves. So, identity access manager roles. That's when companies okay. So warp stream precisely solve when customers, so this security trade-off was precisely problem or stream solved with their data streaming platform. Oh man, I'm so tired. Okay. Might just finish up this and then
Good afternoon,
probably
everyone,
head
and
to
thank
bed.
you for joining our earnings call. We had a strong finish to fiscal. Leverage and positive free cash flow. In fiscal year 2024, subscription revenue grew 26% to $922.1 million. Non-GAAP operating margin improved 10 percentage points to 2.9%, and free cash flow margin improved 17 percentage points. Worst non-GAAP profitable year in the company's history. These results well exceeded our initial expectations across all guided metrics entering the year, reflecting the power of our data streaming platform and our team's excellent execution against our large market opportunity. Turning to the Q4 results, subscription revenue grew 24% to $250.6 million, exceeding the high end of our guidance and representing 96% of total revenue. Confluent platform revenue grew 10% to $112.7 million and accounted for 45% of subscription revenue. Demand for enterprise-grade data streaming in regulated industries remain a key growth driver for Confluent platform.
Yeah.
Confluent Cloud revenue grew 38% to $137.9 million and accounted for non-GAAP profitable year in the company's history. These are all guided metrics entering the year, reflecting the power of our data streaming platform and our team's excellent execution against our large market opportunity. Turning to the Q4 results, subscription revenue grew 24% to $250.6 million, exceeding the high end of our guidance and representing 96% of total revenue. Confluent platform revenue grew 10% to $112.7 million and accounted for 45% of subscription revenue. Demand for enterprise-grade data streaming in regulated industries remain a key growth driver for Confluent platform. Confluent Cloud revenue grew 38% to $137.9 million and accounted for 55% of subscription revenue, compared to 49% a year ago. During the quarter, we saw stable consumption and continued use case expansion across our large customer base, driving robust growth in our core streaming business. Additionally, we saw continued adoption of new components of our data streaming platform. DSP cloud consumption, which includes Connect, Process, and Govern, grew substantially.
So I think actually with that, I should be able to update the model that I had earlier.
Approximately 13%.
I guess this is Q4.
Turning to geographical mix of total revenue, revenue from the percent of subscription revenue. Demand for enterprise-grade data streaming in regulated industries remain a key growth driver for Confluent platform. Confluent Cloud revenue grew 38% to $137.9 million and accounted for 55% of subscription revenue, compared to 49% a year ago. During the quarter, we saw stable consumption and continued use case expansion across our large
Okay, so it's
customer base,
actually
driving
above what
robust
I
growth in our core streaming business. Additionally,
thought.
we saw continued adoption of new components of our data streaming platform. Grew substantially faster than overall cloud and accounted for approximately 13% of our cloud business. Turning to geographical mix of total revenue, revenue from the US grew 20% to $153.7 million. Revenue growth from outside the US accelerated to 26% and was $107.5 million. Earlier today, we announced a multi-year strategic partnership with Jio Platforms Limited, an Indian multinational technology company and a subsidiary of Reliance Industries Limited. By making Confluent Cloud available on Jio Cloud Services and Confluent Platform as a managed service, the partnership is expected to accelerate India's development of Gen AI and next-gen applications, delivering the power of real-time data to more businesses. In the income statement, I'll be referring to non-GAAP results, understated otherwise. While continuing to drive top-line growth at scale, we once again demonstrated significant operating leverage in our model. In Q4, subscription gross margin increased 90 basis points to 82%, primarily driven by the economies of scale in Confluent Cloud. Operating margin was 5.2%, exceeding our guidance of approximately 2%, and was primarily driven approximately 8 percentage points to reach a record high of 11.1%. Net income per share was 9 cents, using 362.1 million diluted weighted average shares outstanding. Fully diluted
162.1. Okay, so I'm a bit overshooting the 12-month range.
Share count under the treasury stock method was approximately 370.1 million. Net income per share was 9 cents, using 362.1 million diluted weighted average shares outstanding. Fully diluted share count under the treasury stock method was approximately 370.1 million. And our balance sheet remains strong, ending the fourth quarter with $1.91 billion in cash, cash equivalents, and marketable securities. Turning now to other business metrics. Q4 win rate for new business once again saw a notable increase both year over year and sequentially. Our win rate against the CSP offerings and smaller startups remained well above 90%. This underscores the strength of
Actually, I don't know what that means. Oh wow, going ahead, okay.
our complete data streaming stability and flexibility and favorable.
Okay, I think this is a good slide then to showcase.
TCO and ROI for our customers. This, coupled with our consumption transformation, has driven a year of high-velocity land and expand. We ended fiscal year 24 with approximately 5,800 customers, representing an increase of 840 customers, nearly double the total increase from the previous year. New customers in the quarter include a top 5 video gaming company, one of the world's largest sports media outlets, a Fortune 100 pharmaceuticals company, a global cruise operator, a leading European airliner, and many more. We also drove robust expansion in our large customer base. We grew our 100K plus ARR customer count to 1,381, an increase of 12% from a year ago. This represents approximately 24% of our total customers, a key success indicator of our expansion strategy
Okay, so I
after
was a
landing a
bit
customer.
bullish then.
These 100K plus ARR customers represented approximately 90% of our revenue. Our 1 million plus ARR customers grew even faster, accelerating to 23% and ending the quarter at 194 customers. New 1 million plus ARR customers include customers from a wide variety of industries spanning financial services, healthcare, manufacturing and logistics, retail, technology, and more. Q4 NRR was 117%, while GRR remained above 90%. Our stabilized NRR in recent quarters, coupled with continued strength in GRR, provides a solid foundation for delivering on our growth target this year. 2025 and beyond. 2024 was in many ways a consequential year. First, we have optimized our pricing and packaging with the introduction of enterprise clusters, freight clusters, and the acquisition of WarpStream. This has significantly increased our serviceable addressable market as we are positioned to deliver best-in-class TCO for a broad range of use cases across self-managed, fully managed, and BYOC deployment models. Second, we extended our technology lead by expanding our DSP capabilities with more than 200 features and capabilities across Stream, Connect, Process, and Govern. With the upcoming Tableflow GA release, we will expand our growth vector by unifying the operational and analytical estates in data management. Finally, we have successfully transitioned to the next generation go-to-market model, focusing our team on consumption-based selling. By increasing consumption of our data powering their mission-critical and real-time AI workloads. As we drive ROI-based expansions throughout our customers' data streaming journey, we expect our growth and profitability profile to strengthen over time. Following a year of substantial transformation, we have established a major data platform for the enterprise, unlocking the power of data streaming for thousands of customers and operating at a $1 billion plus revenue run rate. Given the strong foundation we set last year, we expect to begin reaping the benefits in 2025. Our objective is to continue soaking up the world's Kafka and to establish 2025 as the year of DSP. We will support these initiatives with a resource allocation strategy focusing on efficient growth and prioritizing our investments in expanding our DSP capabilities, hiring and enabling our team to sell DSP, and forming strategic partnerships and alliances. We look forward to driving durable and efficient growth in 2025 as we execute against our large and growing market opportunity. Now let's turn to our guidance. We are providing Q1 and fiscal year 2025 subscription revenue.
Non-GAAP operating margin. Okay, wait a minute. One.
New outlook ahead of.
Okay, so I'm definitely it's a lower on guidance here, and I think total revenue 1121. So I'm a bit above revenue. Yeah, 1166230. Oh, subscription revenue. $1,122. So in line with what consensus thinks. Okay.
expectations. In addition to guiding fiscal year
So, alright, I'm at kind of this 47 delta. 7 million delta.
2025 non-GAAP operating margin within our midterm target set at the time of our IPO. For the first fiscal quarter of 2025, we expect subscription revenue to be in the range of 253 to 254 million, representing growth of approximately 22 to 23%. Non-GAAP operating margin to be approximately 3%.
So maybe then
For
can
fiscal
try
year
to
2025, we expect subscription revenue to be in the range of 1.117 to 1.121 billion, representing growth of approximately 21 to 22%. Non-GAAP operating margin to be approximately 6%, and non-GAAP net income per diluted share to be approximately 35 cents. I'd also like to provide a few modeling points. We expect the first half of fiscal year 2025 will be approximately 46.5%, in line with the average of the first half seasonality in the last 2 years. For cloud revenue, we are
so free cash flow margin 6% of 6% of 1 billion. 60 million free cash flow, right? 10% would be 100 million. So I think I am actually modeling above what the street is thinking. Yeah, I have 80 million in free cash flow by 2025.
Estimate for fiscal year 2025, and we expect to see approximately 1 point of increase in cloud subscription revenue mix each quarter, with a Q4 25 exit of approximately 59 to 60%. For free cash flow margin, we expect a one-time negative impact of approximately 15 points to Q1 25, or approximately 3 to 4 points to fiscal year 2025, resulting from a change to timing of cash compensation payments for most of our non-go-to-market employees. Excluding this one-time impact, we expect adjusted free cash flow margin for fiscal year 2025 to be approximately 6%. In closing, a strong finish to 2024 is a testament to our large TAM, the market leadership of our technology platform, and our world-class team. Powered by the secular tailwinds of cloud, data, and AI, we are incredibly excited to take advantage of the market opportunity ahead. Before turning to Q&A,
so definitely something wrong is with this.
If you are interested in attending in person, please contact the IR team at
I wonder if I can go.
During the Q&A, please click on the raise hand icon. When selected for Q&A, we ask that you limit yourself to one question and one follow-up. And today, our first question will come from Matt Pepper with RBC, followed by Wells Fargo. Matt, please go ahead.
Great, thanks a lot, Shane. Congrats, team, on the results. Really strong into the year. I guess weeks ago about Snowflake potentially looking at acquiring Red Panda. Today, you announced a really excited, expanded relationship with Databricks. I guess I'm wondering, could you talk more at a high level of how customers think about using Confluent for streaming and processing outside of analytics?
Okay, so I think I'm gonna end this here, It is already 12 o'clock, so I need to get some sleep, but probably need to wake up early tomorrow and actually post this on Substack and update my team. So thanks for tuning in. Catch you guys in the next one. Peace.